It's all like wood stuff, really. There's not really metal stuff. Gotcha.
Today we are going to talk about the generators. But if you know, in the previous topics, it's a lot of theory, no? You see the videos, you see the book. It's a lot of theory. My friends, I am happy if you call to Danny or me any moment. You can call on Saturday, Sunday, no, Danny? We don't have any problem.
As long as I hear the phone ring, because I'm somewhat deaf. Bro.
If you want to pass for our place, the place of Danny or my place,
yeah.
You are very welcome. Okay? No problem.
I just want to. You guys are all watching the videos, right? I know you guys, like Albert and I were talking. You guys all kind of look like deer in the headlights, you know.
Yes,
to do this.
well.
I understand the video is really, really important, and that book's important because there's only so much we can teach in the couple hours that we have here. So that's why it's important that you grasp as much information through the videos so you can ask those specific questions here. So it just makes an easier transition for you, okay? Because I know people, I know video takes time, but those videos are good. They're really, really good.
You can repeat and repeat. For example, yesterday I explained quickly how to check the capacitor. You remember? The capacitor. But you have a clip. Who checked the video clip about the capacitor? Yeah. In the clip I explained with details, once again, the connection of the multimeter, the selection of the diodes, no? Yeah. There are videos for everything in the website, okay? All right, guys. Okay, we're going to start with generators. I mentioned that if you are a good technician in generators, in my opinion, this is the technician with more possibilities because this is the area where you receive better payment in marine industry. All the areas in marine industries are excellent. If you want to be dedicated to fiberglass, great. If you want to be dedicated to hydraulics, great. If you want to be dedicated to air condition, excellent. What area is bad in this?
No,
region?
there's no bad area. I would say fiberglass is a unique individual that has to work on fiberglass. The pay is phenomenal because not many people want to do it. Okay, I do it because I have to do it for my own shop, but I don't do like major structural repairs. I have people that do that. Fiberglass is pretty hideous. It can be itchy. Well, you'll see when you're in my composite class, you guys are gonna feel itchy all the time, and that's normal. But you can design a lot of cool things. Like I'm building my boat right now. It's cool because you actually the engines it's already there. You actually can fabricate things yourself and make things and buy an old boat and put new bulkheads and stringers and all that. And you're gonna learn how to do that, you know. And again, there's only so much time, but here's the deal: when it comes to the composite, I would say 80% of the time will be here, because I'm gonna have you grinding and fiberglassing, and I wanna teach you guys how to paint. You'll probably either do gel coat. I'm gonna see if I can get the school to get all grip instead of a gel coat. Gel coat's a little bit of a pain in the butt. So after you paint it, you have to do a lot of prepping. But you guys are gonna get that experience, at least a little taste of it. And like we had some students from previous classes. Oh, I like the fiberglass.
And
okay,
they are
dedicated. We need more people like you, man. There's not many people out there that want to do it. And the fiberglass guy is important because if you got to make a stringers bad, and there's a video, I don't know if you ever finished that video, the one the stringer popped and the motor popped.
Oh, yeah, this is one of the videos.
It's going to come in this class?
In this class.
Yeah, there was a boat that came in the shop, and the stringer was so rotted that the motor fell on top of the other motor. It was an straight inboard. So we took videos at the shop, pulling the motor out, had the stringers redone. It's structural support. So we need fiberglass, people. It's good money, really good money. Probably more money than most parts because not many people want to do it. But it's nasty work, and I'd rather not if I don't have to. I do it because I want to do a certain thing. But the good thing about this whole course is you get a little taste of everything. Generators, the motor part to me is easy, and the electrical part now I'm more familiar with because I don't really do generators. And air conditioners I don't do very well because I work on the smaller ends of the boat, you know. So, but here at least you get a taste of everything. The hydraulics, you're going to get in the hydraulics and all that because if you're working on those mega yachts, you got big hydraulic systems. There's a lot of systems. So you need to be well-rounded. If you're going to be an engineer and a big yacht, you need to know everything. I wouldn't say a jack of all trades, a master of none, but at least here you have an experience. And again, once you apply that experience, I promise you, everything will click, and it'll be easier. You guys are way ahead of the game. Way ahead of the game. You don't even know it yet, but you will once you get out there. And you'll see how quickly you move, because if you work for a marina and this guy, like someone like me that doesn't know diddly about ABYC, then you come in there and you follow the standards, because the boating industry wants to follow that ABYC standard. You guys are the next generation replacing people like me that didn't have that ability or wasn't around during that time. So now, basically, it's kind of like we're breeding in the ABYC standards, which is good. It's good standards. Safety. People didn't care back then. People used to fiberglass holes in gas tanks. You can't do that. It's a fire hazard. But those are the things. All right.
Okay, guys.
Sorry about that.
It's clear how the alternator works, no? But the generator is basically an engine with an alternator here. For that reason, if you see the theory, how many types of generators are? Two types. Alternator type, or generator type. What is the other name for generators? Armature type. Armature type. Okay. Two types. But both of them at the end are the same. Why this is called alternator type?
For AC, alternating current.
Because the excitation, the electromagnets are produced on the rotor. The excitation with the brushes is here in the rotor. It's clear, my friends? In the alternator type. Oh, in the stator type, the excitation is produced on the stator, and the AC power is produced in the rotor. It's opposite. But at the end of the day, it's the same. What is more efficient? Alternator type or generator type? Both of them are the same. Some manufacturers, like Northern Lights, Western Big, they produce the majority of your generators alternator type, and the other ones generator type. Both of them are equally efficient. I don't see the difference. I have years working with generators, and both of them are highly efficient. My strong area is generators. This is the area that I work for a long time, working, repairing, installing, calculating generators. For that reason, at the end of the chapter, I'm going to explain the procedure to calculate a generator for that boat. The people say, oh, I have this boat and I want to install a generator. What generator is recommended? Normally the people say, 5 kilowatts. How you calculate 5 kilowatts only checking the boat outside? Because the length of the boat, because the weight of the boat. It's not according with that. It's according with how many loads you have. Oh, I want to install a big refrigerator, 2 air conditioning equipment, 7 fans, light, this. You added, you calculate the total power in kilowatts. And with that power, you convert in horsepower to calculate the engine of the generator, and you calculate the generator. This, I'm going to explain the procedure. It's simple, but you need to know how many loads are in my boat, right?
Yeah.
Okay. Other of the inconvenience, no. Other of the important things when you try to install a generator in a boat, one thing is the calculation, sizing the generator. We are going to learn that procedure later. The other one is where I am going to install the generator inside of the boat. Because to install a generator, the generator is composed by the engine, gas or diesel, and the alternator or back end. Everybody follow me? What is better, with diesel engine or with a gasoline engine? In my opinion, with diesel engine. It's more reliable. is more efficient. Today, a lot of boat owners with gasoline boats, with outboard gasoline boats, they install diesel generators. We installed one, no, Danny?
Yeah, on a
Recently in a boat,
yeah, it was a 30
with 2 outboard
cent.
gasoline, no?
Yeah, it's a gasoline Mercury 4-stroke outboards. You put an air conditioning system and a generator.
And generator diesel.
Tell them where that generator was up here.
Because the diesel is, we are going to learn in the next coming class in diesel and gasoline. Diesel is too simple. For diesel, you only need compress the air, inject the fuel, and ignite. You don't need wires, you don't need nothing. The diesel engines are too simple. The diesel engines are more reliable, more efficient. Okay, for that reason, the people prefer every day more and more diesel generators.
As far as the positioning of the generator, explain to them where that generator was at.
Now we are going to check where can I install the generator inside of the engine room. There are different places. Normally the people say, oh, in that corner, because this is the only area that I have in the engine room. We are going to verify if that area is good for the engine, because we need verify where I am going to bring the fuel from the starboard side tank or from the port side tank. Where we are going to return the fuel, because if the generator is diesel, you need fuel coming in and fuel coming out, the return. And the exhaust pipe, where I am going to put the exhaust outlet. And the batteries, where will be located the batteries. And the raw water pump, where should be located the raw water pump with raw water. Because the engine, internally, you have coolant, exactly the same like your car. But the coolant is cooled not with the radiator and the fan that you have in your car. It's cooled for a heat exchanger with raw water. Okay? Alright, I need raw water, I need fuel, I need the exhaust, I need the batteries, and I need the remote panel. I need to identify where I am going to locate the remote panel, where I am going to locate the exhaust manifold and the muffler, where I am going to locate the batteries. The batteries should be exclusive batteries for this. Can I use the same batteries of the engine? No. Can I share the house battery? No. It's an exclusive battery, exclusive for the start motor of the generator. That's okay? Exclusive battery. The fuel tank, can I use the starboard side tank or the port side? Yes. Yes. This is normal. As close as possible. If the generator will be close to the starboard side, okay, use that tank. That's normal. But you need separate raw water filter, raw water pump, raw water through hull for this generator. Can I use the same through hull for the starboard engine? No. Starboard engine with your own through hull for raw water, and the generator with your own through hull for raw water. Fuel line separated from generator and the engine. Completely separated, isolated. The generator is an individual unit. Ready? And the remote panel.
I would just add one more thing, and make sure that you can put an area that you can service it. Don't bury it, and you can never service it. Okay? The boat that Albert and I did, that generator was literally, when I tell you, in the bilge. You had to crawl down a hatch, go down a bilge. So we had to redesign, and we actually put the bilge where the access hatch was, so that when you open the access hatch, it's accessible right there. And we made an access hatch on the back side of the transom that has a door, so if I had to change the starter, I don't have to pull the generator out. So you gotta think, it's not just throwing a generator in and finding space, you gotta service it. It needs servicing, so if you put it in a place you can't service it, every time that guy's gotta service it, you gotta tear the boat apart. You don't wanna do that. Yeah.
Does weight affect it too? Let's say, like, we're talking about big boats, so
yeah, you need to verify that.
Yes, weight. In our case, the one that Albert and I did, it was already positioned in the back, but they had it literally. When I tell you, when it was in the bilge, right, Albert, that was like in the bilge.
In the bilge with
in the bilge.
water.
in the water. That's why, and then we told the guy, says if I reinstall it in the same place, there's no guarantee. Because you already know it's going to get destroyed. So we position it in an area that's above, literally above the deck, and we had to redesign the whole thing. The guy paid for it, he was okay with it, he has the money, but now it's nice, because we can service it. He can even service it himself if he wanted to.
How many calls we received after that installation?
I didn't get one call.
Never.
I got one, he thanked
Yeah?
us. Let me tell you about customers. They don't call you, they're happy. When they call you, 80% of the time it's like, oh, here we go. But every once in a while you get that phone call, like, here we go. And like, oh, thank you. I just want to tell you how happy I am. Oh, okay, thank you. I was just like, oh shit, here we go.
Yeah.
It's really the case. Very seldom does a customer call you back and say, oh man, thank you so much, it was great. They don't call you, you did good.
Okay, go ahead.
I got a couple questions. So why would the battery just separately be for the generator?
Oh, okay. Basically because you remember we have normally 4 or 5 group of batteries in a typical boat, no? One group of batteries for cranking, other group of batteries for a house, other group of batteries for generators, other group of batteries for bow thrusters, and probably in a big boat, other for electronics, no? Okay. For example, the electronics batteries should be exclusive for electronics. When we talk about electronics, we are talking about the radar, the GPS, the transducer, the fish finder, all of those electronic devices. Those electronic devices should have a separate group of batteries exclusive for the electronics. What happens if you connect the electronic devices connected with the cranking batteries?
If it died.
The cranking batteries, especially in big boats, diesel engines, introduce a lot of noise, interference, especially during the cranking and during the operation also. And you affect the performance of the screen, the performance of the displays. That's not good for electronics. The cranking battery should be exclusive for cranking or engines. The house battery should be for house. But the generator is considered another motor. It's another engine, no? You need an exclusive battery for the generator. Normally, I install this one with a switch selector with a bypass to the house batteries. In case of emergency, this battery is not working, I use the house battery. But this is in some specific design. I recommend exclusive, and the manufacturer recommend exclusive batteries. If you install this one with the batteries of house or cranking, if you have problems in the future and the inspector enter in the boat, immediately check that the pen of order and no warranty. You need to be careful with that. Okay, the recommendation is separate group of batteries. What type of batteries is recommended for this?
Cranking?
Cranking batteries. Because the battery is used only to crank the engine. After that, the generator continue running, producing your own power with the alternator of the engine. Yeah, producing your own power. The battery is exclusive to start. After that, the generator produces your own DC power with the alternator of the engine, and of course the AC with the back end. Ready?
One more. So this is like for like a medium-sized boat, like a 50-footer?
Yeah, this is no for a small boat. Because this is 5 kilowatts, no?
Okay.
This is 5 kilowatts for a boat like 30 feet, 35 feet.
Yeah, 35 feet.
But it's not the size of the generator is not according with the length of the boat.
Yeah, it depends on how much...
It's with the loads.
Okay.
With the load.
What is the biggest generator you've seen?
No, in my experience, I installed until 250 kilowatts in mega yachts, and 3 generators, 250 each one. No,
Wow.
no, it's because in a mega yacht, in a cruise boat, you need power from the generator constantly, all the day. Suppose that you are anchored in a Virgin Island, and the boat is rented with 20 people. You need AC power all the time. Each generator runs 8 hours. 8 hours, stop, start the second one, 8 hours, stop, start the third one, and start again, the cycle. For that reason, you need 3, in some cases 4, 6 hours each one. The generators never stop. Never stop. You need minimum 1 generator running all the time. That's clear? Nice, no? Who is the captain in Virgin Islands? It's not here.
No, you're thinking about Cam.
They
Cam's
can.
not here.
Okay.
That's
Alright.
how we did it in the Navy, though.
Yeah. Four generators. Yeah.
4 generators, 4 engines.
Yeah. Normally, is 3 in big boats. I install and I repair a lot of them. If you have 3 and you have problem with one of the generators, okay, you can isolate that generator during the period of the reparation and you work with the other 2 long period of time, no? Okay. Okay, great. This is the engine. Don't forget, raw water, fuel, batteries, and you need the raw water, fuel, batteries,
Control box.
and the exhaust. The exhaust, that's the most important part. Okay. What is the most critical factor in the decision where I am going to locate the generator? Here, or here, or here, or here, or here. What do you think is the most critical factor?
Water line.
Accessible.
Accessible is number 1.
Water line.
The level of the water line. Where is located the level of the water line? Like Danny mentioned before. A generator located below the water line, it's not because the raw water enter and touch the generator. No. It's because it's easy, if the generator is located below the water line, it's easy that when the pistons are moving down, suction salt water, because the salt water pass through the heat exchanger close to the exhaust manifold. Right now I am going to explain that. It's easy that the piston suction water if the generator is below the raw water. Who has knowledge about engines, gas or diesel? A little, you Danny, also? You? All right, I want to explain something. I want to explain something quickly. In the next course, I will explain with a lot of details in the videos of gas and diesel. Oh, thank you. That's the anti-side. Pay attention. We are going to think, who know why you say this engine is 4 strokes or 2 strokes?
The open.
The amount of movement of the piston, no? Okay, I'm going to explain quickly the 4 strokes. But pay attention. This is nice explanation. This is the piston. And this is the head with the valves. Intake valves and exhaust valves. All right. The piston is, this is the, normally you have 4 strokes. Intake, compression, power, and exhaust. 4 strokes, 4 movements. Ready? Okay. Normally you start with the intake. In the intake, in gasoline engines, you suction air and fuel in gasoline. In diesel, in the intake, you suction pure air. Okay. We are going to simulate the intake movement. The piston is going down. And what about the valves?
They open?
Both valves open?
No.
Only
Intake
open. Intake open. And the piston going down. And fill the cylinder with air or with the mixture. Ready? Now the piston is in the bottom. What happened with the valves?
Close.
And the piston start to
Push.
compress. What happened when the mixture is fully compressed? The spark plug ignite and send the piston down. Explosion. Number 3. What happened with the valves during the explosion? During the compression? Close. During the explosion? Close. And now the piston goes up in exhaust. Exhaust valve open, intake stay closed, the piston goes up and the gases goes out. Nice. Those are the 4 strokes. Nice, no? Okay. Okay, pay attention. When the piston is going down, only the intake valve is open and enter air and fuel. Okay, in gasoline or only air in diesel. Okay, and in what other moment are valves open? During the exhaust. During the exhaust, when the piston is going up with gases here, the exhaust valve is open and push out the gases. Okay, in 2 moments. Okay, let me explain quickly the exhaust manifold. Look, sorry. if you have a head, can we move one head quickly?
Yeah.
If you have a head, in each cylinder you have intake valves and exhaust valves. Intake valves and exhaust valves. The intake valves are communicated with the intake manifold and air filter. Yes or not?
Yes.
The intake valves. If you remove the intake manifold, you see the intake valves. And the intake manifold have the air filter. In the exhaust valves, you have the exhaust ports, and the exhaust ports are communicated with the exhaust manifold, and the exhaust manifold with the exhaust pipe. That's clear?
Yes.
All the heads, any type of heads, you have intake valves, exhaust valves. Intake, exhaust in each cylinder. The intakes, intake, communicated with the intake manifold and air filter for intake. And the exhaust, communicated with the exhaust manifold and bye-bye, gases. Simple, no?
Yeah.
Look, this is the exhaust manifold. Oh, nice, thank you. This is the head of my Jeep. This is nice. Look, in each cylinder you have intake, exhaust, intake, exhaust, no?
Yeah.
And if you see, in this particular, it's not a good example. In the majority of the engine you have, this is exhaust, and the squares are intakes. Now, you have intakes and exhaust. In the majority of the engine, intakes are in one side and exhaust in the other side. In this one, because the design, you have intake and exhaust
The same side.
in the same side. For that reason, it's complicated explanation. But suppose that I have intake ports here and exhaust port here. The intake ports are communicated with the intake valves, and the exhaust port communicated with the exhaust valve. Nice, no? This is the head. Okay, look at this.
Professor, on that one, the intakes were a little bit bigger than the outtake?
No, the exhaust a little
okay,
bigger because the gases are expanding. Okay, look. This is the sorry. This is the exhaust manifold. Exhaust manifold, connected, bolted on the exhaust side of the head. Look, gases, and the gases goes here, enter in the exhaust pipe, and bye-bye. It's clear?
Yes.
Okay. On top, here, we have a heat exchanger. The heat exchanger, you have coolant, look, the coolant enter here, and the coolant return into the block of the engine. And the coolant is cooled by raw water, by salt water. The salt water coming from the raw water system pass here and goes out over there. Look at this. In this point, the salt water is mixed with the gases. And in the exhaust pipe, marine engine, you have gases mixed with water. Yeah? Is because on top of the exhaust manifold, you have the heat exchanger. And the heat exchanger have coolant, and the coolant is cooled by raw water. The coolant, the salt water never touch the coolant, because the coolant is moved in a serpentine of pipes, and the raw water pass around those pipes. Never touch. You never have mixed coolant with raw water. This is the only area in this portion that you have salt water.
The water's to cool the coolant?
To cool the coolant. That's it. And the raw water not enter in the engine. The head is here and the engine is over there. The raw water enter here, pass through the heat exchanger, goes to the exhaust, and bye-bye. The raw water enter in the engine? No. The raw water is exclusive for this heat exchanger. Good? Is clear the explanation? Okay, let me explain something. Those are exhaust. And here, in between the exhaust manifold and the heat exchanger, you have a metal. It's separated. The gases never touch the raw water. The gases are mixed with the raw water only here in this point. You see? Raw water enter here and gases are here. In that moment, the force of the gases push the water out. And the water goes out with the gases in the exhaust manifold. That's clear, my friends? In a boat.
Yep.
Okay, look, the raw water is here. And those are exhaust manifold. Here in front of this, you have the exhaust valve, exhaust valve, exhaust valve, exhaust valve. Pay attention. When the engine is running, when the exhaust valve is open, the pressure of the gases going out pushes the water out. Look, this is the heat exchanger. This one is similar to this. Look, coolant enter here, the coolant circulate over there, and the coolant goes out here. The coolant enter here coming from the block of the engine, if the thermostat is open, enter here, and return into the block of the engine and circulate in the block. Coolant, thermostat, coolant, thermostat, coolant, clear? And now, raw water in the middle. The raw water pass through those pipes. You see? Hey, Papa.
Yeah, I'll pass it to
Those
you.
pipes are pipes. The raw water pass over there, and the coolant is around the pipes. The coolant don't touch the salt water. The salt water enter here, and the salt water continue over there. This is the heat exchanger. I have a question. The gases are in contact with the raw water or the coolant?
Only the
No. Why they put this heat exchanger over the exhaust manifold?
To cool it.
In order to keep the temperature of the exhaust manifold
Low.
lower. Great. Perfect. That's the heat exchanger.
Let me
Thank you,
pass- Let
Dan.
me pass that around. So you can see.
That's the heat exchanger. That's the heat exchanger located over the exhaust manifold. Okay, pay attention to this. During the cranking, not when the engine is running, only during the cranking. Crank, 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 crank. During the cranking, the piston move like this, until the first explosion. No? What happened? During the cranking, the pistons are moving 1 time, 2 times, 3 times, boom, and start the engine. No? That's in your car. Crank, 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 boom, start. How many rotation of the crankshaft? Probably 4 or 5 before the engine starts. Any type of engine. Follow me, because this is the most critical part. What happened if during the intake, okay, the valves are calibrated. We are going to explain later the procedure to calibrate the valves in order that the valve open only the moment that you need and the period of time that you need exactly. No more, no less. Okay, what happened if the valves are not calibrated and when the piston is going down during the intake, which valve is open? During the intake.
The intake.
Intake valve is open, no? Only intake valve. What happened if during the intake, the exhaust valve stay open a little? What happened with that water? When the piston number 4 is going down, how much is the pressure when the piston is going down? How much is the pressure? It's negative pressure a lot. What happened with the water here if in this piston, in the piston number 4, the exhaust valve stay open a little during the intake? Salt water enter. When salt water enter in the combustion chamber, in the moment of the explosion, the piston unlock the engine and destroy the engine. No, Danny?
Oh yeah.
This is catastrophic. Why? Later we are going to explain why. But it's basically because the expansion of the metals of the aluminum is twice in comparison with the expansion of the iron. The piston expands twice and the cylinder in iron 1 and block the engine. This is basically the explanation. But later we are going to talk about that. This is only when salt water enter. Okay? Oh. For that reason, excuse me, I have one thing. Look, if I have this engine installed below the water line, what means?
So the pipe's gonna be full of water.
You have full of raw water here in the exhaust pipe. Oh, if the engine is located over the water line, what happened with the raw water here?
Doesn't come through down.
You don't have raw water. Only if you crank and the raw water, suction water, and bring here. For that reason, if the engine is located in the limit of the water line or a little below, you need install in this hose, you move this hose here up, and you install one hose going up and return down, and after that enter here. What is the name of that elbow?
Anti-siphon.
The anti-siphon. What is the idea? If the engine is below the water line, the water enter here, but stay here. No continue. Only continue if the engine start and the raw water pump it, pass over there. You understand, my friends? For that reason, when you install a generator, this elbow where the gases are mixed with the raw water is here, this elbow, the limit of this elbow is the key point. Where is located that one with respect to the water line? Oh, the water line in this engine room is here, and the generator will be located here. What happened? You need what? You need anti-siphon. If the engine no start immediately and you crank, suction water, finito. Oh, that generator is new and it's, you damage. No, I don't damage. Okay, the inspector arrived to the boat, water line, done, no warranty. Who installed? Oh, that Mickey Mouse technician. Hialeah. That's critical, my friends. You can destroy it. This is the most expensive element inside of the boat, the generator. Good explanation? It's clear?
So you're saying the engine and the engine head has to be a certain distance between the water line?
Okay,
and
between
the water line? Or not above the
no,
water
depend on the situation.
Depends the application.
Exactly. But normally the recommendation is the anti-siphon should be going 12 inches over the water line and return minimum. The anti-siphon.
And will you always need the anti-siphon?
Only if the generator is in the limit or below the water line. If it's over the water line, you don't need anti-siphon. Thank you.
Fresh water have the same effect as salt water?
No, that's different. Your engine in your car, suppose that for any mechanical problem in the motor, the coolant is fresh water, is passing into the combustion chamber. What is the symptom? Coolant. When the coolant enters in the combustion chamber, what is the symptom? You have white smoke. And when you check the oil is milky. But the engine continues running. But if a small amount of salt water enters in the combustion chamber, that's critical, that's different.
It's pretty amazing how salt water. I had a customer that we put a used motor on his boat. He redid his boat himself, whatever. He went to use it. The boat literally ripped the transom off the back of the boat. He sunk the motor. It was in the water for like, I think 2 weeks on the water in Loxahatchee in the Everglades. He brings me the boat. We pick it. We get it running right away. It's been sitting for almost 3 months. So I went to. He came by the other day. He's gonna install it on another boat. It's not frozen. If that was salt water. Here's the deal, any motor that goes underwater, you have to get it running right away. You have to pickle it. When I say pickle it, if it's gasoline, take the spark plugs out, turn the engine over, get all the water out of the combustion chamber. And the whole idea is to run it with gas and oil mixed together and run it for at least minimum 3 hours. Why would I want to run it for at least minimum 3 hours? What does that do? It dries all that moisture that's in the bearings, in the crankcase and all that. But fresh water is way more forgiving than salt water. Salt water is unforgiving. You leave it 2 days out of water with salt water and it's locked. And once it locks, because the metal that's inside the engine is really only protected by oil. Well, if you got water in there, there's no more oil protecting. So the metal, what happens with iron? It rusts, rings, they get stuck. So that's why salt water, that's why the anti-siphon valve, just like you said, if you don't do it right, guess what? You're buying that. Or your marina's buying it.
Would you consider brackish water fresh water?
Brackish water
Yeah.
is considered raw water.
Yeah, it's the same to a degree, but salt water is just. Go ahead.
What's that piece called again?
Which one?
This top one that Mr.
one.
Lopez.
It's the heat exchanger.
Yeah, that's a heat exchanger.
That's
the heat exchanger.
the heat exchanger, and this is the exhaust manifold.
Okay.
Now, can you imagine how interesting will be the gasoline and diesel classes?
Oh, wait, you have
Those
no
classes
idea. You guys
are
got
wonderful.
fun.
And we are going to disassemble the diesel engine completely here, and we are going to repair the engine. This is a nice class. We hope you enjoyed that class. But you know that this is a process. You remember in intro we start with the file, and day per day we are moving. You feel different, no? Today. Okay. All right. This is a short introduction about the engine, only to explain that you need install the generator. Depending where you install the generator, you need the anti-siphon or not. Okay. Other important thing is if the generator is gasoline than this, normally you don't need return line into the fuel tank. If the generator is diesel, you need a suction line and return line. Normally in diesel engines, 20% of the fuel entering in the engine is used for the explosion, and 80% of the fuel return into the tank. A lot of fuel return, no? A lot of fuel return. For that reason, the return line is a bigger line, because the fuel returning is hot and it is expanded. Okay? Later we are going to learn about it.
I just want to make sure I'm getting this right. The generators have engines to rotate the rotor, right? The whole part of the engine in the generators is to rotate the rotors?
Okay, the rotor is bolted on the flywheel of the engine. It's bolted on the flywheel. That's the rotor. Oh, here. Yeah. Let me show this to you. You enjoyed the class, papas? See the videos. In the videos I explained. Look, this rudder is bolted on the flywheel. You know who is the flywheel? It's the wheel with to engage the start motor. You remember? That's the wheel. This one bolted on the flywheel. The flywheel is bolted on the crankshaft. The crankshaft moves the piston, no? All right. When the engine is running at 1800 RPMs, the rotor is spinning at 1800 RPMs. If the rotor decreases the RPM, because it's connected, it's bolted on the crankshaft. This rotor is spinning constantly at the speed of the engine. No? Finito. This is the back end. The back end is composed for the stator and the rotor. You see? The stator and the rotor. And it's exactly the same like the alternator. You remember? You have the rotor and you have the stator. A little bigger, but it's exactly the same. It's exactly the same. In this rotor, the rotor is bolted with an engine. In this rotor, the rotor is connected with a belt, and the belt with the engine. Or I can connect a sprack with a chain, and I connect my bicycle. No? That's other type of generator. Okay, great. This is the generator. And now, if I install the generator properly in the proper location, depending with respect to the water line, this is one consideration. Other consideration is that generator will be located exactly over the propeller. Yes, the propeller is behind of this. Oh, yeah. This is an inconvenience. Why?
Frequency.
Because the frequency. No, my friend, that place is not good for the generator. We need other place, separated from the location of the propeller. If not, I introduce vibration in the boat. All right, this is other important thing. And other important thing is be careful with the water in the bilge, like Danny explained in the boat that we repaired some months ago.
You ever take video when we took that motor off?
Yeah,
thing
but
was a rust. I mean,
no,
like I
it's
said,
it's in the videos.
Oh,
Check
that
the
one's in the
yeah,
video
it's
too?
Part of, yeah, it's part of the videos. It's part of
that
the
was
video.
by far the worst. And here's the worst part: to get the generator out, because the generators, they must have put that generator on when they built that boat.
Uh-huh.
Because
It's
the only
original.
way the generator, I had to manhandle it to get it as close as possible, and the generator had to be lifted one end to go like this to get it out of the hole.
Yeah, it was.
Dude, it was.
No, but I have
By far
another
the worst.
other videos. I replaced the generators in one of the boats of Mark Antony a couple of years ago, and a big boat was necessary. Cut the deck
Yeah.
outside the deck in order to introduce the crane and lift the generator vertical. That's a chirurgical operation. Oh yeah.
The rest of the water.
Yeah, the rust. Yeah. This is the generator. Yeah, this is because was located below the water line. Yeah, thank you. We have a generator donated for him. We are going to use that generator in the class of diesel to repair that engine. That's nice. Nice project. Okay, guys. Until this point, any other question about the location of the engine? Be careful with the location close to the propeller. Be careful with the level of the water line. Be careful with the bilge, because the bilge is normally full of water, and when the boat is inclined, the water goes, but that's not good. Try to install the generator as higher as possible. As higher as possible is better. All right? That's important. Good point? Okay, now we are going to be concentrated in the back end, the rotor and the stator. And if the generator is properly installed, the battery is properly installed, you are doctor installing the battery, the positive of the battery goes directly to the positive terminal of the start motor, and the connection is too simple. We are going to do the wiring, the harness of the generator in the next coming class. We are going to do the installation of all the gauge, the sensor, everything together. Okay, this is a nice class. Okay, the generator is running, and immediately you start the generator. Start, preheat, stop. That's clear? Start, preheat, stop. That's the button. When the generator starts to produce power, you turn on the breaker, and this breaker sends the power to the main breaker to the switch selector. You remember? And after that, to the main breaker on the AC panel. Good. I have power on the breaker of the AC panel, and the customer complained. The generator start is running. I see the phases, phase 1, 120, phase 2, 120. You remember, you installed the gauge. But the generator, after 2 minutes, shut down. And of course, the code on the display is low frequency. You are the doctor. The customer calls to you. What is your answer?
Engine's not running fast enough.
Radiator.
Not running
I don't know
fast
what it's
enough.
called, but
The heat exchanger?
Say it again.
The heat exchanger, you say?
No, the radiator, the alternator.
The alternator is okay. This is, pay attention. This is great. He said that the alternator of the engine is not producing power. It's possible.
It's something with power. I know that.
It's not producing electricity.
Yeah.
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 This is
Engine-
one possibility.
Your engine's not running.
Excuse me?
RPMs, you're not running fast enough.
Okay, why?
Too much load.
No, remember, thank you. What is the recommendation when you start a generator? The breaker is off.
Off.
And all the breakers in the panel?
Off.
Off. You start the generator with the breaker off, and turn on, and after that, go to the panel, verify, phase 1, phase 2, and after that, you start with single loads. Lights, fans, fan, air condition number 1, and you hear the generator and recover. Okay. Air condition number 2 and recover. Full load and good voltage, 120, 120, 60 hertz, 60 hertz. Happy. Let me wait, like Danny say, 2 hours. 2 hours.
We gotta check all the light bulbs.
No, 2 hours. You drink a coffee. You wait in the boat. with full load the generator. After 2 hours you return, you check the temperature of the exhaust elbow. The temperature is okay. You check voltage, frequency, and you check for the engine oil pressure and temperature. Okay, the generator is running good. Let me I turn off all the breakers, off. I turn off the generator, off. I check the oil, no milky. I check no leaks. I start again. Run, I start again. I check voltage, frequency, and I apply load again. You understand? Never start the generator with the load.
So that's what happened. He had his.
What happened
so much
is
load going on.
that the rotor, if you start the generator with all the load, the rotor tries to touch the stator. Because it's too much load, no? And you can make a short in that moment when the rotor hit the stator. This is catastrophic.
You usually have to wait for 2 minutes, right? It'll happen like right away most times.
It's very common.
Yeah.
It's very common. Or the customer calls to you and says, I don't know, but the generator is knocking. Tack, 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 tack. And you see the phases are balanced. 60 amps in one, 60 amps in the second one. It's pretty close, both of them. But the rotor is touching the stator. It's because yesterday, my friend, you start the generator 2 times with full load. Oh yes, I did that. The rotor touched the stator, and right now it's unbalanced. That's not good. This is very common. If you remember, I said in intro, you need a good magnet, number 1, and a small multimeter, pocket multimeter, volts AC, volts DC, and heat gun to check temperature. Where should be? Here,
Exhaust.
the elbow of the exhaust. The elbow of the exhaust. What is the temperature? Depend of the manufacturer. Check here and check in the thermostat housing. Where the thermostat is located, check the temperature. The temperature in the thermostat housing should be the same temperature that you have in the gauge of the temperature. With this. That's okay? Great, you need that one. Always. This is a great question. Thank you, Danny, for bringing this. Let me explain something.
Cheap and harbor free.
Yeah. This is good. It's harbor free. I love it.
Harbor Free.
Oh, I think like $9.
Look,
Have it too.
this is the typical elbow of the exhaust for a generator. Look, the gases enter here, and
The water.
raw water enter here. And here is the mixture, gases and raw water. The generators, especially the marine generators, they have one sensor. There are 3 sensors, 3 switches that kill the engine in emergency. One of the sensors is the temperature sensor located in the thermostat housing. If the temperature of the coolant pass the limit, the engine stops. Other sensor used to kill the engine is the oil pressure sensor. If the pressure of the oil pass the limit, the engine stops. And other sensor is this. It's located here. It's touching this metal in the elbow. It's the exhaust gas temperature sensor. If the temperature of the gases pass the limit, is an indication of what? Look where it's located. It's here.
It's not being cooled.
It's because no raw water is coming in. You need verify. Oh, the generator, the gases, but no water. I have a problem with the raw water system. Raw water pump, the raw water filter, the strainer, it's clogged.
That means it's gonna overheat.
For that, no. The engine stops to avoid overheating. Immediately the temperature of the gases pass some limit, that sensor sends the signal to the computer and stop the engine. Exhaust gas temperature sensor. Where is located?
On the
In the elbow of the exhaust, where the water and gases are mixed. Good?
Yeah.
Exhaust gas temperature sensor. Thank you, Danny. And for that reason, my friend, you need the magic tool. Where you check the temperature? Look, here. What is the temperature? Check the manual of that generator, because each generator is different.
That tool he has in his hand comes in really handy because some motors will have a hot spot. There might be a blockage somewhere in the block, and you can isolate it and check different places. Hey, the thermostat's running really nice, but man, the exhaust is really hot, or maybe the one side of the block is hot and the other side's cool. It helps you find it, you know. Now, if you didn't have one or the battery's dead, I have a rule. If I can hold my hand on there for at least minimum 5 seconds, it's good. If I can't hold my hand more than a second, that thing's smoking hot. Now, you guys' hands haven't got to my hands yet, but your hands will be callous enough that sometimes you can do it over, but it's by touch. But again, they didn't have the infrared heat gun back then, so everything was touched by hand. Or we had also the wax. Remember back then they used the wax? There was a wax that you put on there, and if it changed,
Melted it.
that would know. But that doesn't exist anymore. But the infrared heat gun, $9 at Harbor Freight, you should buy 2.
No, this is an important tool.
Yeah,
You need buy different 2 or 3 of these to keep one in your car, other in the toolbox. Or, because you need always a heat gun. Not only for generators, for gas engine, diesel engines, for water maker. You need a lot of
application.
applications. Yeah.
If you're doing a sea trial, make sure you have heat gun too.
Yeah.
Yeah, what?
If you're doing a sea trial,
Oh,
have your
absolutely.
heat gun. Because you want to be able to repair something, you want to be able to see it before it blinks at the captain. That's the last thing you want to do.
You need to be familiarized, like he said, with your engine, with your boat, with the odor of your engine room, with the temperature. For that reason, Danny and me, we are going to explain in each course the gauge that we recommend install in the engine room. You only open the hatch of the engine room and you see the gauge. The gauge for the fuel pressure is okay, it's in the range. The gauge for the pressure of the hydraulic fluid in the power steering is good. The gauge for in between the fuel filters of the diesel engines to indicate if the elements, the filters are in good condition is good. There are a lot of gauges that you need to be familiarized. Only check, oh, that's good. In 30 seconds you say if the engine good. Oh, smell hydraulic oil, smell battery electrolyte. Only with the odor, only with the pressures on the gauge and temperature, you know if your boat is in good condition. You need to be familiarized with this. We are going to explain in each course what gauge is recommended, where it should be located, and what is the function. Okay, right? All right. My friend, the only that we want, Danny and me, is that you enjoy this class.
And learn.
And learn, of course.
Learn.
But we want that you enjoy the class if you participate in class. And you participate in class only if you read the book, if you follow the videos, if you ask questions. We are happy responding questions. We never hide to avoid questions. No, we are ready to respond questions, okay? To solve that question. Okay, my friends. We are going to continue. The engine run and stop suddenly. What is the most common possibility for that situation? The engine run, 30 seconds, and stop.
Too much load.
And you have low frequency. No, because I recommend start the generator with no load. You wait 2-3 minutes. After that, you start applying load.
Your alternator.
In that moment, no load is applied.
It's not
You check
producing
the
power.
alternator, the battery. That's perfect. It's not a DC problem.
Check the fuel. Fuel.
It's a fuel problem. It's a fuel problem. It's a fuel problem. Probably the fuel filter is clogged. You have restriction in the fuel. You have fuel issues. Normally, it's when the people replace the fuel filters, the primary filters or the secondary filters. Normally, especially in diesel engines, you replace the filter and you have bubbles. If you have bubbles, never start again a diesel engine. You can start a gasoline engine with bubbles? Yes. No problem.
Run like crap, but it'll run.
Tira peo.
The bubbles will eventually.
Tira peo. Pero start. No problem. The diesel engine start? No. With a small bubble like this. No start.
Oh, where would the bubble come from?
Okay. The bubbles come in the moment that you remove the filter and you install the new one, you introduce bubbles. For that reason, you need to bleed the system before you start the system. We are going to explain the procedure to bleed here in class. How many times?
Yeah. All I can tell you is when you're changing any filter, you should automatically fill up the filter before you put it on. And then, especially in the diesel, then you prime it.
Yeah.
Gasoline's the same way. We just fill up the filter, put it on, and then that way you don't have to sit there, prime it, or let the fuel pump. It makes a quicker transition. Because especially in the diesel, if you run that completely out of fuel, you're gonna have fun getting that thing back up.
Like he's saying, the priming, if you don't fill that fuel filter out, and they have a primer, the big Caterpillar engines have a primer.
Correct. The primer pump that you bring.
And the big fuel filters are about this big, and if it's not filled up, you're just sitting there pumping for about 45 minutes.
Correct. For that reason, you have. Look at the fuel injection pump in a diesel engine, my friend. Look, this is the fuel injection pump. This is the fuel coming in from the priming pump. Enter here. And after that, internally, look at this. The pressure here is 14 psi, 14, 15 psi, coming from the transfer pump, electrical transfer pump or manual or valve priming pump, 15 psi. And in the output, how much is the pressure in the output?
What, like 25,000?
3,000, 5,000, 7,000, 25,000 psi. Here in this output, what happens if a small bubble of air enter here at the input in the low pressure side? What happens internally when that bubble is compressed? Expand and block. And block. And block. And no more fuel is flowing. That's simple. You understand? It's here the problem in the fuel injection pump. For that reason, you need split the air. And after that, boom, start. No? Air. Okay. That's the problem. The engine stops. My friend, you have checked the fuel. No, it's okay. Why is okay? Because yesterday I replaced the filter. That's the problem. That's the problem. Yeah, that's the problem. Finito. No more conversation. Okay, Mr. Lord, can you visit the boat? Yes, 250.
And that's a question. Listen, and that's a question because some customers will do it themselves. Oh, it's just changing the filter.
Ah, simple.
And then you say, oh, I just changed the filter. Did you have this problem before you changed the filter? No. That's why you have to ask questions to customers because they're not going to volunteer the information. Yeah. Oh, when you were running everything, so, yeah, I did my own filters, and now you have the problem. Okay, and then you explain to them like he just explained to you. Explain to him so he understands.
And the people respond, oh, I have a car 50 years ago, and I replace the oil and fuel filter each 2 months. Okay, but this is in your car, gasoline engine. This is a diesel engine, marine engine. That's different. Okay, great? Yeah. Good? All right. Other possibility that the engine start and stop suddenly is the air filter. When the air filter comes, finito. Stop. No? Finito. You can run when you finish immediately. No? Because you don't have air. Yes or not?
Yes.
Okay. The people never pay attention to the air filter. The technicians normally replace the oil, flush the oil, replace the oil filter, no problem. And never pay attention in the fuel filter. Be careful with the generator because normally the generators have a sun shield enclosed, no? The sun shield, and the sun shield is covered internally with foam, with insulation.
Insulation.
That insulation is fiber, and that fiber clogged the air filter, and the air filter is clogged easily.
And a lot of engines, even outboards have that. Some of the outboards have that foam insulation.
That foam is
garbage.
Is fiber. That fiber is suction in the air filter. That fiber past the air filter in some cases, enter through the intake valves in the combustion chamber. Is fiber, glass. What is glass?
Silicone.
Glass is sand. Is sand in the finito. No? All right. Is fuel or is air? Number one. Number two, the customer complain. Oh, the engine is running, the generator is running, and produce power, but I have 120 in one phase and 0 in the other phase. 120 and 0.
It's not wired right.
Okay, what is the first element that you need verify in the generator?
The output volt.
The control box.
Of course, you have here the breaker with phase 1, phase 2, and neutral, no? You need verify with the generator running the voltage between phase 1 and neutral, 120. Between phase 2 and neutral,
120.
120. But in the panel, I only have one. What is the problem?
Connection.
The wire, the harness in between this and this. Okay, here, 120, and the second one 0. Let me isolate the phases. This is phase 1, this is phase 2, and this is neutral. Let me start the generator. And now, yes, 120. And now, 0. This phase is producing 0, no voltage. I need verify the winding of the back end. We are going to use, I forget bring that, the megometer.
Mega.
Can you check the video how to check an engine with the megometer? Let me say to Diego, and Diego sent to you that link.
Is the word he just said, is that same in a multimeter do the same thing?
No.
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 Watch
Okay,
the
I am
video,
going to
you'll
send to
see.
your WhatsApp the video to check to use the megometer.
Well, next class we have, we'll have it.
All right. We need check the condition of the winding in the rotor with the megometer. Check that video, the megometer. Okay. One phase, each one should be 120 and 120, no? One phase is 180 and the other one 80 volts.
Broken neutral.
The neutral, where is open? Where normally? You remember this element? That one? Here. All the generators, they have that box. Smaller or bigger, but they have that box. In this box, here, look at the box here. That one is here, where the phases are connected and the neutral and the ground. If you check this, or you check this, neutral and ground are together. If neutral and ground are together, you see, neutral and ground together, in some cases you see the neutral cable disconnected or the ground broken, disconnected. It's disconnected here, in the point where ground and neutral are connected. The neutral is broken or is disconnected. For that reason, you have high voltage in one phase and low voltage in the other. Great? Good? Okay. The generator start, run, but 0 volts and 0 volts.
Breakers
Okay. Number 1 is verify the breaker. Oh, yeah, the breaker. I forget the breaker. Okay, turn on the breaker. Oh, yeah. Oh, no, yeah, I turn it on. 0 and 0. Oh, no, it's not the breaker, Papa.